All right, that's fine. Okay, good, good. I mean, I know it was on here, but I was trying to show you how you can get it on your own. Okay, so we have cosine of 10 degrees is adjacent over hypotenuse. Okay, that's what we get. Cosine of 10 degrees is adjacent divided by hypotenuse. Cosine of 10 degrees is A divided by 4. We want A. Okay, well, how do we get that? Well, it's really just like before, right? We want to isolate it. We want to isolate A. We want to get it all alone. So what we can do is multiply both sides by 4. Okay? You know, when you do that, you can see, just like in the previous slide, right? These A's cancel. You get cosine of 10 degrees times 4 equals A. I put the 4 over here, but again, multiplication, you can multiply in any order you want. Multiplication is commutative. So we have 4 times the cosine of 10 degrees is A. Now from here, right, we want to get A. And again, I like to put the unknown on the left side of the equal sign. You really don't have to. But for 4 times cosine of 10 degrees, again, what you need to do is use your calculator. You have 4 times cosine of 10 degrees, okay? As you can see. So this is cosine of 10 degrees, the 0.98 stuff. Multiplied by 4, this is where we get A is. It's about this. Again, on the exam, I'll tell you how many decimal places to round to. Okay. Now we have to get B, but are there any questions so far? Okay. Now, for B, the opposite side, right? I mean, here I say you have to use sine. Now, how do we know that? Well, let me show you. I mean, we know B is the opposite side. We have the hypotenuse. B is the opposite side. So we have opposite, hypotenuse, right? O and H. That gives us sine. So we can see then that since we have opposite and hypotenuse, we need to use sine. So that's what we have. So sine of 10 degrees is opposite, which is B, divided by 4. Right? We have B divided by 4. And that's what we have here. So now we have to solve for B. It's really just like the previous question. Namely, we want to get B all alone. Right? So what do? Let's multiply both sides by 4. By doing that, we're getting B all alone on one side of the equal sign, right? Because we cancel off the 4's. So we have sine of 10 degrees times 4 equals B. That's what we have here. Okay, good. All right. And of course, that's the same as and that's what we get here. Same thing. We want B. So from here, we get B as 4 times sine of 10 degrees. I just, again, interchange you can multiply in any order you want. Sine of 10 degrees, this comes from a calculator. So we do 4 times that. And when you do that, this is what you get. All right, that's cool. Okay. So any questions on this? All right. Okay, so here, I know this was just like a question on the test, but I figured it wouldn't hurt to go through it. So let's say we want to find a quadratic function so that the vertex is 1, 4, and the graph passes through the point 2, 6. So the graph passes through 2, 6 as well. So I don't remember if we called this the vertex form, but anyway, it doesn't really matter because this is the form you're going to want to use. Mostly because it's easy to write in h and k, mostly because we have the vertex. I mean, I guess you could use the other form we had, which was ax squared plus bx plus c, but then you have to calculate a, b, and c. I mean, I'm not saying you can't do that, it'd just be more involved, more tedious, maybe that's a better word. But here, hk is the vertex, right? We know the vertex. HK is the vertex, so we have these 2 points are equal. So that H has to be 1, right? And K has to be 4. You know, if 2 points are the same, they have the same corresponding coordinates. So we know H is 1, we know K is 4. We substitute. We're not done though, because we don't know what A is. But that's okay though. And why is that? Because we have this other point, 2, 6, that's on the parabola, you know, on the graph that is. In other words, when x is 2, we have to get back 6. So f of 2 must be 6. Remember, if you're given something, you know, you want to use it. They give it to you for a reason. You know, if I didn't tell you that it went through this point, there would be nothing else we can do. Okay. So f of 2 must be 6, as we just said. Okay, so we have 6 then equals a times 2 minus 1 squared. I'm replacing x by 2 plus 4. Okay. So this is what we get here. When x is 2, we get 6. So let's simplify this side here a bit. So we have a times 1 squared plus 4, which is, of course, a plus 4. So we have 6 then equals a plus 4. And we want to know what a is, right? So what do? We solve for it. So we can do that by subtracting 4 from both sides. We get 2 equals a. So a equals 2. All right, that's good. So now we know what f of x is. And we can check as well using Desmos. You know, we can sketch the graph of this in Desmos and see, do we get a parabola whose vertex is this and passes through this point? You know, don't be afraid to use Desmos as a check. But before I go to Desmos, are there any questions on this? Let me go to Desmos now to illustrate what I mean. So we're in Desmos now. So let's go to Graphing Calculator. So again, we could type it in. We could type f of x equals 2 times x minus 1 squared plus 4. So here we might have to move around a bit. So we can always click with the mouse, hold and move, you know, click and drag that is. But again, I mean, you could zoom in if you want. Click here, click and drag a bit. So let's type in some points. We could type in, for instance, 1, 4. You can click label. Okay, so we can see that, yeah, this is the vertex, right? That's where the graph changes direction. Actually, let me say this first. It definitely looks like a parabola, right? We know what that shape is. This is where the graph changes direction, so that's the vertex. Now, what about the point 2, 6? Is that on the graph? Well, yeah. See? We can see from here that 2, 6 is on the graph, so our answer must be right. Good. Okay, so thanks to Desmos, we know we got the right answer. Now, let me stop this. Let's go to window. I'm just bringing back the notes. So that was one example. Let's do another one. For this one, we have another example. Now we want to find a quadratic function such that its vertex is 3, 5, and it passes through the point -1, -4. So it passes through this point. Now, okay, so again, it's just like before, right? We can use this form. If you use the other form, you can do that, just might take more work. But here we know that HK is the vertex. So just like before, we have HK is equal to the vertex, 3, 5. So that means H is 3, K is 5, right? So we put it in. But again, we're not done yet, right? Because this A could be anything. Although I'm sure if you think about it for a bit, you would know if it's positive or negative at least, but that takes a little bit. Anyway, we don't have to do that because we have a point on the graph. We have a point on the parabola, right? This. And since -1, -4 is on the parabola, this is telling us that f of -1 must be -4. So f of -1 must be -4. Okay, that's good. Okay, so we're going to use that, right? When x is -1, we must get back -4. So that's what I'm using here. So we replace x by -1. We do some calculation, right? We have -4 equals this. We get a times -4 squared plus 5, which is a times 16 plus 5. Here I wrote 16a, but if you left it as a times 16, that's fine. So we have -4 equals 16 times a plus 5. Okay, we solve for a, right? That's what we're looking for. So we subtract 5 from both sides, get -9 equals 16a.